All right, guys, last section in chapter 13, and it's graphing. You didn't think doing all those charts the other day was going to be the end of the fun of your 8th grade algebra year, did you? Here we go. Okay, graphing rational functions. First of all, what is a rational function? A rational function is a function expressed as a ratio of polynomials whose denominator is not, what do you think? 0. Okay, so the first function that we're going to look at is a function in the form f of x is equal to a over x. So example number 1 says graph f of x is equal to 2 over x. First thing we need to do is determine what are our excluded values. Okay, in this case, x cannot equal 0. So we do not need to come up with a coordinate point in our ordered pairs that is 0. All right, now let's go ahead. X, f of x is equal to 2 over x. Now, I'm going to do a bunch of coordinate points for this one, and I'm going to talk to you after I'm done graphing it as to why. But I'm just going to go x, -4, -2, -1, -1/2. I'm not doing 0, even though we almost always do 0 for x, but that's an excluded value. We can't have it. It's undefined, okay? Now I'm going to go positive. So when x is -4, 2 over -4 is -1/2. 2 over -2 is -1. 2 over -1 is -2. 2 over -1/2 is -4. 2 over 1/2 is 4. 2 over 1 is 2. 2 over 2 is 1. 2 over 4, is 1/2. Okay, now we're going to come over here and grade. My grid lines are going to be each worth a half. Okay, so this is 1, 2, 3, 4, -1, -2, -3, -4, and 1, 2, 3, 4. All right, so -4, -1/2, -2, do it the right way, Mrs. Wilkening. -4, -1/2. Oh, that's a terrible place, but that's where it is. -2, -1, -1, -2, and -1/2, -4. Right here. And that graphs like so. And then take a look at 1/2 and 4. 1, 2, 2, 1, and 4, 1/2. All right, this particular graph is called a hyperbola. Hyperbola. The ends of each branch of the hyperbola in example 1 approach but never actually reach the x and y axes. No matter how far these guys go, they might get really close to the x and y axes. They are never actually going to touch them. Therefore, the x-axis is what we call the horizontal asymptote. Sorry, took a mental break for a moment there, okay? And the y-axis is the vertical asymptote. okay? These asymptotes are indicated by dashed lines. So I'm just reading from your book, so let me do that right here. So here's the axes, and I'm just going to mark those with dashed lines to show our asymptotes. So the asymptotes are the lines where the two branches of the hyperbola will approach, okay, but never actually intersect, all right? The center of the hyperbola is at the intersection of its asymptotes. So in this case, when we have an asymptote of x-axis and an asymptote of the y-axis, where do the x and y-axes intersect? Well, they intersect at point 0, 0. So the center of this hyperbola is at the center of any hyperbola, excuse me, is at the intersection of its asymptotes. So in this case, it's at 0, 0. Now, let's look at a rational function in the form of f of x is equal to a over x plus k, all right? And specifically, we're going to look at f of x is equal to 2 over x plus 3. So the 2 over x looks very similar to example number 1, but now we have this plus k, all right? Which values are excluded here, all right? Which values are excluded? Since the function is undefined, okay, undefined when x equals 0 is the equation of the vertical asymptote, okay? So let me say that one more time. Since the function is undefined when x is equal to 0, x equals 0 is the equation of the vertical asymptote. Okay, so we figured out when it's undefined. Now we're going to go ahead and make a table of some ordered pairs. X, and we have f of x is equal to 2 over x plus 3. I'm going to choose the same x values as we did before. Okay, so 2 over x, 2 over negative 4 is negative 1/2 plus 3. Which is 2.5, okay? 2 over negative 2 is negative 1 plus 3 is 2. 2 over negative 1 is negative 2 plus 3 is 1. 2 over negative 1/2 is negative 4 plus 3 is negative 1. 2 over 1/2 plus 3 is 4 plus 3, so that's 7. 2 over 1 is 2 plus 3, that's 5. 2 over 2 is 1 plus 3, that's 4. 2 over 4 is 1/2 plus 3, that's 3.5. Same as I did before, I'm going to have each one of my marks be worth 1/2, which means I'm going to have to extend a little bit past my graph. Just want to check where I need to do that. Okay, I need to do that up here. So 1, 2, 3, 4, 5, and we're just going to keep this guy going. 5, 6, 7. Okay, so we're going to go up there. All right. And then 4, 3, 2, 1. Negative 1, negative 2, negative 3, negative 4. I need to start marking these axes before I do the problem, so you don't just have to sit there watching me do that. Okay, so when x is negative 4, f of x is 2.5. So 2.5. When x is negative 2, f of x is 2. When x is negative 1, f of x is 1. And when x is negative 1/2, f of x is negative 1. Okay. Graph this branch of the hyperbola. And then we have 1/2 and 7. That's going to be all the way up here. 1 and 5. 1 and 5 right there. 2 and 4. And 4 and 3.5. Okay, here's the other branch. of the asymptote, okay? So we've graphed it. All right, now we need to figure out what is our point, okay? What is our center point of this one, okay? Our center point is at 0, 3. That's the center point of this hyperbola, okay? Observe that the graph f of x is equal to 2 over x plus 3 is the result of translating the graph of f of x is equal to 2 over x 3 units what direction? We moved it 3 units up, okay? The graph center and horizontal asymptote have been moved up to 0, 3. And y is equal to 3 is our horizontal asymptote. We draw that dashed line. Y is equal to 3. Sorry, I said horizontal. That's vertical. My bad. Okay, so that's a terrible color for that. Here we go. So here's our vertical, and here is our horizontal. Okay, here's our horizontal. All right, so I stopped and paused for a minute because I just realized I'm being kind of a goober. Oh, and I'm also doing this in Seahawks colors, which I didn't realize. Okay, y is equal to 3. When y is equal to 3, that is our horizontal. I don't know why I crossed that out when I had it right the first time. And the vertical is x is equal to 0. So sorry about being confusing on that one. Okay, so let's make a general rule based on what we just saw here. Okay, the graph of f of x is equal to a over x plus k is the result of translating the graph. So we're translating the base function of f of x, or the base graph of the function f of x is equal to a over x, k units up if k is positive, and k units down if k is negative, okay? Example number 3 says graph g of x is equal to negative 6 over x, all right? So when is this graph undefined? Our graph is undefined when x is equal to 0. So that means x is equal to 0 is our vertical asymptote for this graph, okay? We've determined the value for what the function is undefined. We have our vertical asymptote. Now we're going to graph, so we're going to make a table of ordered pairs. We're still going to do a whole bunch of ordered pairs because we want to make sure we get a good picture of our hyperbola, okay? So you want at least 4 coordinate points, okay, in each quadrant where the branches of the hyperbola exist, all right? And as you get more familiar with graphing these and what happens with translations and those sorts of things, you're going to be able to figure out where your hyperbolas are going to live and where you should pick some x coordinates, to plug into your function. But it just takes a little practice, okay? So let's start with what if x is negative 6. So if x is negative 6, okay, sorry, that should say g of x. Then g of x, or y, is going to be equal to 1 because negative 6 divided by negative 6 is 1. What if x is negative 4? Okay, then we have 3 halves, okay, or 1.5. If x is negative 2, that's going to give us a positive 3. And if x is negative 1, that is going to give us a positive 6. We don't pick 0 because we know it's undefined at 0. And now we're just going to work in the opposite direction with our x's being positive. So if x is 1, y, or g of x, is negative 6. If x is 2, g of x is negative 3. If x is 4, we end up with negative 3 halves. And if x is 6, we end up with negative 1. Now, same thing. I'm going to say each of these grid marks is 1/2. Okay, so x is negative 6. 1, 2, 3, 4, 5, 6. So that gives us 6, 1. right here, or negative 6, 1, negative 4, and 3 halves. Whoops. And that should be here. That's what I get for not writing this. I was like, I don't need to write it. Yes, I actually really do, or else I'm going to lose track. So negative 4. And hopefully you guys just caught what I did wrong on that one too by trying to speed this along and get this done for everyone. Am I even going to have room for a negative 6 over here? I really kind of don't. We're just going to sort of make it work over here. It's as far over here as we can possibly get it. We'll do it that way. Okay, then negative 4. 1, 2, 3, 4, and 3 halves. It's going to be right here. Negative 2, 3, negative 2, 2, 3 is right here. And then negative 1, 6, so 3, 4, 5, and we'll put 6 up here. So negative 1 and 6. So that guy, and remember, I did a terrible job with this 6, but this one's going to go like so. Okay, just terrible job at the end. And then we have when x is 1, okay, y is negative 6. 1, 2, 3, 4, 5, and we're going to say negative 6 is down here. So 1, negative 6, 2, negative 3, 1, 2, negative 3, 4, 3, 4, and negative 3 halves. 1, 3 halves, and then 6. So 4, 5, we're going to say 6 is out here, and 6, negative 1. We're going to call that right there. And this guy is going to go like this. So sorry, that graphing was super painful, okay? Now, we already determined that our vertical asymptote is x is equal to 0. And guess what else? Mr. Wilkening thinks he's being funny right now. Okay, what is our horizontal asymptote in this case? Well, because we don't have anything happening over here, we're not adding or subtracting a k, then our horizontal is also 0, okay? So y is equal to 0, x is equal to 0, and our center is 0, 0, okay? So x is equal to 0 is the vertical, y is equal to 0 is the horizontal. All right, in example number 3, when x is a very large positive value, g of x is negative and very close to 0. Likewise, for a very large negative value of x, g of x is positive and very close to 0. This indicates that the line y is equal to 0, the x-axis is the horizontal asymptote. Since the vertical asymptote is x is equal to 0, the graph's center is at 0, 0. Notice that the negative value of a causes the graph to be located in the upper left and lower right quadrants formed by the asymptotes. Okay, so what that means when we have a negative a, okay, negative a, we're going to have our branches in this quadrant and in this quadrant. Okay, example number 4, graph h of x is equal to negative 6 over x minus 2, and then compare that to the graph in example 3. First of all, we need to figure out, okay, where are our excluded values. X cannot be what? X can't be 2, okay, because that would make this undefined. So x cannot equal 2. So x is equal to 2 is our vertical. I can't spell tonight. Is our vertical asymptote, okay? Now, determine or make a table of ordered pairs. Let's go ahead and do that. X and h of x, negative 6 is equal to x, or over x minus 2. So when x is negative 4, we end up with negative 6 over negative 4 minus 2. So that's negative 6 over negative 6. So h of x is 1, y is 1, okay? When x is negative 2, that's negative 6 over negative 2 minus 2. Okay, negative 2 minus 2 is negative 4. So negative 6 over negative 4 is 3/2, okay? When x is 0, x can be 0 this time, okay? X can't be 2, but x can be 0. So we have negative 6 over negative 2. That gives us positive 3. How about when x is 1? Okay, when x is 1, we get negative 6 over 1 minus 2. So that gives us positive 6. When x is 2, that is undefined, okay? When x is 3, negative 6 over 3 minus 2. So that's negative 6 over 1. So that's negative 6. When x is 4, that's negative 6 over 2, which is negative 3. When x is 6, that's negative 6 over 6 minus 2. That gives us a negative 3/2. And how about when x is 8? That's negative 6 over 8 minus 2. That is negative 1. Okay, so we're going to come over to our graph, and we are going to graph this guy. And I learned in my lesson last time, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Please do not just stand here and awkwardly stare at me while I'm making a math video. It's super weird, super creepy. Find something to do, okay? Okay, and you're just really lucky that I'm not saying what name of what kid it is in this video right now. Walk away. Thank you. Sorry about that. I'm sure Marcus will tell you all about that tomorrow. Okay. Negative 2, negative 1, negative 3. I'm just filling in some random ones here. All right, and let's get started. Negative 4, 1. So when x is negative 4, y is 1. Here we go. When x is negative 2, y is 3/2. Negative 2 and 3/2. 2, 3/2 right there. 0, 3. And 1, 6. So I've got to go up 5. Call this 6 right here. 1, 6. I'm going to put that guy right about there. And here's that branch. Then 3, negative 6. And 5, 6. Here's negative 6 down here. So 3, negative 6. 4, negative 3. 6, negative 3/2. This is going to be fun. Call that right here. And 6, negative 3/2. We're going to put that right about there. And then 8, 5, 6. We'll say that's 7. And we'll say this is 8 over here. And we have 8, negative 1, and 8. All right, I did not do the best, but it's just going to go like so. Okay, sorry, my graph is not amazing or stellar right now. Okay, so we've graphed, okay? Now, take a look at this graph, all right? Take a look at this graph. We already determined that our vertical asymptote, okay, vertical asymptote is x is equal to 2. So that's this guy. Here's our vertical asymptote at 2, 0, okay? So our center is at 2, 0, and our horizontal asymptote is at y is equal to 0. So if our horizontal asymptote is at y is equal to 0 and our vertical is at x is equal to 2, what is the center of this hyperbola? It is 2, 0. 2, 0 is the center. And this graph, okay, this graph is the result of translating the graph of g of x 2 units to the right, where g of x was this one, okay? And we've just taken that negative 6 over x, and we've moved it 2 units to the right, okay? Now, I'm going to switch colors because that green's getting hard for me to see, okay? The graph of a function in the form y is equal to a over x minus h plus k is a translation of the base function y is equal to a over x. It is a hyperbola with its center at hk. And a vertical asymptote of x is equal to h, and a horizontal of y is equal to k. You will need to choose several points on either side of the hyperbola's center to determine its exact shape. But this is key for this lesson, okay? Example number 5. Given f of x is equal to 2 over x plus 3 minus 1, identify the center of the hyperbola, both asymptotes, and then graph. So this is in the form of f of x is equal to a over x minus h plus k, all right? And remember, we said our center is at hk, and the vertical asymptote is x is equal to h, and the horizontal is y is equal to k. So let's identify those in this function. F of x is equal to 2 over x plus 3 minus 1. Here we have h, okay? Here we have k. Now, what's interesting about h is that take a look at our skeleton formula up here. That's x minus h, okay? This right here says x plus 3, all right? So really, we could rewrite that as x minus negative 3, okay? X minus negative 3 plus negative 1, okay? Plus negative 1, because that also looks similar but different, okay? So our center of this asymptote is at negative 3, negative 1, which means our vertical, did I say asymptote? I said the center of this hyperbola, and the vertical asymptote is that x is equal to h, okay? So x is equal to negative 3, and the horizontal is when y is equal to k, so y is equal to negative 1. So now we have both of the asymptotes and we have the center. Now we're going to go ahead and graph this. Make a table of several convenient points on either side of the center so that you can figure out the general shape of the graph. So the center is at negative 3, 1. So negative 3, negative 1. So here is our center, okay, at negative 3, negative 1. And our asymptotes pass through this guy, okay? So we want x values that are going to help us to put that parabola in this quadrant and this one, okay, on both sides of the center, okay? So x and f of x is equal to 2 over x plus 3 minus 1. So we're going to go negative 7, negative 5, negative 4, negative 3, negative 2, negative 1, and 1. Why are most of my values for x negative? Because look at where this where these vertical asymptotes, because they intersect in the negative quadrants for both the x and the y axes, and down in quadrant 3 on this coordinate plane, the majority of what's happening that we can see so that we can graph both branches of this hyperbola is happening when x is negative, okay? So when x is negative 7, and I'm just going to kind of breeze through this part because this video is already getting really long, y is negative 3 halves. When x is negative 5, y is negative 2, negative 4, negative 3. When is this undefined? It's undefined at x is equal to negative 3. So that point does not exist, okay? When x is negative 2, y is 1, -1, 0, 1, -1/2. And now let's just graph some points. So x is equal to -7. I am not even going to be able to fit this. Actually, let me change the way. Sorry, you guys. It's been a day, and I shouldn't really be even trying to wrap my brain around algebra right now. But so I'm going to go back to each one of these being worth 1 instead of 1/2, because that's going to allow me to get that -7 on here. So 1, 2, 3, 4, 5, 6. Here's -7. So -7 and -3/2. So we're going to say this is -1 and this is -2. So -7, -3/2 is going to be right here. -5, -5, -2, -4, -3. Remember, -3 is undefined. -2, and then I'm going to go up to 1, okay? And then I have -1 and 0 and 1 and -1/2, okay? So you can see what's happening here. And let me go ahead and pop that center on here as well. 1, 2, 3, 3. So here's the center. So there's that. And what did I do? X is -1, 0, and, oh, I see what I did. Boop. That should be up here at -1/2. There we go. So one branch of our hyperbola, second branch of the hyperbola. Both branches approach the asymptotes, but will never actually intersect with them, okay? That is how you work through example number 5. Now, the graph of f of x is equal to 2 over x plus 3 minus 1 is the result of translating the graph of f of x is equal to 2 over x. That's the first one that we started with. 3 units left and 1 down. 3 left and 1 down. Notice the similarity to the translations of the absolute value, power, radical, and quadratic functions that we studied earlier. The table below summarizes the families of functions studied in this course and their key characteristics. So you're going to come back to these functions a ton in Algebra 2, okay? And as you continue to move on in your math career, but all of these functions, the one obviously that we're really focusing on for this section is this right here. So this is going to be the key for chapter 13, okay, where we have a general form of a function, f of x is equal to a over x minus h plus k. The variable is in the denominator. There's an example, and then we always have these characteristics where the center is hk, the vertical asymptote is x is equal to h, and the horizontal is y is equal to k. All right, that's, I think, yep, and that's the end of this lesson. Sorry it was so long.